Hello everyone, and welcome to this video on graphing a quadratic function combining horizontal and vertical shifts. In other words, we're going to be graphing quadratic functions of the following form. F of x, or y, equals, and we have the quantity x minus h squared, where h is a real number, and then after that, outside the square, plus k, where again k and h are both just real numbers, so like x minus 2, the quantity squared, plus 5, or whatever. Alright, or x plus 4 squared, and then afterwards minus 7. Okay, just where h and k are real numbers. Alright, so this is a kind of a continuation of the past couple of videos I've put out on function transformations. So if you'd like to look those up, in one video I talked about vertically shifting a graph up or down, right? A vertical translation. And in the video after that, I talked about horizontally shifting a graph, shifting a graph left or right so many units, or in other words, horizontal translation. So in this video, I'm going to go over a quick refresher of those rules. When is a graph going to be vertically shifted or horizontally shifted? How can you tell? And then we're going to actually do some examples where we're looking at functions like this on the bottom of the page here, f of x equals x minus h squared and then plus k, and just doing a couple examples of that. Alright, so I'll begin with a recall of function transformations. So I've already written all this out. So yeah, function or functions transformations. We're talking translations or shifts here, right? Just moving left or right and moving the graph up and down, without actually changing the shape of the graph. So the first of these is the the vertical shifts. How do you tell when you have a vertical shift? So suppose we're given the graph of some function, say y equals, and what we're going to be starting with in the examples for this video, as in the previous couple videos, we're going to start with y equals x squared. Right? So this f of x, again, is just some expression that has x in it, depends on x. So y equals x squared, y equals x cubed, y equals the square root of x, whatever. So say we're starting with the graph of y equals, f of x. And then what you do to this rule, this f of x, to cause a vertical shift is simply leave the rule the way it is and then just add k, right? Add some number to the original rule. So you leave the rule the way it is and then add a number to it. So you see I have y equals f of x plus k, or f of x plus k in both these cases. Now if you add a positive number, right, here's the first case, case A, when you add a k and k is greater than 0, k is positive, that's going to take the original graph and shift it up k units. And all you would need to be doing in either of these cases is, just adding this k number to all the y coordinates of the original graph, and then it'll shift your graph up k units, or down k units if k is negative, and that's the second case, case B. If I have y equals, the original rule and then plus k, but k is a negative number, k is say, negative 5, minus 5, minus 7, that's going to shift the graph down, I say the absolute value of k units, just to make it, because when you talk about moving a certain distance, that should be a non-negative quantity, so that's why I say absolute value of k. But you just really add k again. You're adding k to all the y coordinates, and if k is negative, that's going to shove everything on your original graph down so many units. Alright, so that's again a quick recap of vertical shifts, and then on this next page I have a quick recap of your horizontal shifts. Right. So for horizontal shifts, how can you tell when that's going to happen? Well, again, suppose we're given the graph of some function, and again, what I'm going to start with today is y equals, x squared, but it's really y equals any rule that depends on x, right? So that's y equals f of x. then how you can change this rule to cause a horizontal shift is, you don't add or subtract anything on the outside. You don't leave the rule the way it is, like you did with vertical shifts, right? Vertical shifts, I leave the rule the way it is and then add something. Here you do something, you change the rule entirely, right? You don't leave the rule the way it is. What you're doing is you're taking y equals f of, and notice how x is changed in the parentheses in the argument in the input place to x minus h for both of these. Y equals f of x minus h. So if you want to cause a horizontal shift in a graph, you have to do the thing in the bubble down here. You replace every x, replace each input in the original rule with the quantity, x minus some number, right? X minus some h. So that's what this f of x minus h stands for. You're replacing every x in the original rule with some quantity x minus h. Alright, well, if you do this, if I replace all the x's with x minus 3 or x minus 5, where that number, that h is positive, x minus 5, x minus positive 4, that will shift your original graph to the right, that h units. And if you're going right or left, and again, you see up or down, I have arrows in both of these. In either case, you're going to be adding h, whatever h is, to all the x coordinates, right? That'll move you to the left or to the right if you change the x coordinates. And the other case, case B, is if I replace all the x's in my original rule with the quantity x minus h, but h is negative, so x minus negative 5, which would really be x plus 5, or x minus negative 3, which would really be x plus 3. So really, if you replace x with x plus a number, then the graph will shift to the left by the absolute value of h units, right, or h units. And again, you're just adding that number, that h, to all the x coordinates. If it's a positive number, everything moves right. If it's a negative number, everything moves left. All right. So again, just a quick recap of the past couple videos on when can you what causes a vertical shift or a horizontal shift. All right. So let's look at our examples. Right now, I have a couple examples where I'm asked to graph the following quadratic function using horizontal and vertical shifts. All right, so graph each quadratic function using horizontal and vertical shifts, and I'll show some points on the graph. Right, we'll label some points. Right, so I've got f of x, or y, equals, and then the quantity x minus 3 squared plus 2. Alright, so when you're asked to, if I'm asked to use shifts, right, like they're asking me here, that means you're using function transformations. So I'm going to start with a very basic function. Alright, now I notice here that this expression has a variable squared, right? This is a quadratic function. So I'm going to start with, if I'm asked to use transformations, shifts, whatever, I'm going to start with the most basic quadratic function there is, and that's y equals x squared. Right? That is the most basic quadratic function, most basic, the graph of it will be a parabola. Alright, so I'm going to start with that rule, y equals that rule. And I'm going to graph it in red, and I'm going to do each of the every time I move it around, every time I shift it, I'm going to graph it in a different color. Hopefully that comes through on the video. And then on another page, I'll graph what the final graph should look like, what the graph of y equals x minus 3 squared plus 2 should look like. All right, so y equals x squared. And I've got my x-axis and y-axis here. I'm just going to have every square represent one unit. So 0 squared is 0, and I've graphed this on past couple videos a couple times, so I'm not going to make a table. You can make a table, right? And even when I was asked to graph this, you can always make tables. All right, I'm not going to be doing that here, but you can make a table if you want and plot a bunch of points, and hopefully you get like 5, 6, 7, 8 points. You plot enough points to where you see a pattern forming and then fill in the rest of the pattern. You can always do that. It's just if you know what transformations are occurring, if you know what shifts are happening, it'll make graphing this a little easier than guessing what I should plug into a table. So the origin's on there, 0, 0, right? Again, I'm graphing y equals x squared to start, the most basic quadratic. 1 squared is 1, so I have the point 1, 1. Negative 1 squared is also 1. Positive 2 squared is 4. So 2, 4. 2 for x, 4 for y. And negative 2 to the second is also 4. Right. And I think that's enough points. Right? Again, I've put this up several times in previous videos if you want to watch those, but if I fill in the rest of this pattern here, and I'll do it in this, again, in a reddish color. And there's y equals x squared, right? The most basic parabola, most basic quadratic. Now, I'm going to try to, one step at a time, all right, one step at a time, performing one transformation, one shift at a time. I'm going to try to change this rule, the x squared rule, into this rule. I want to have at the end y equals x minus 3 squared and then plus 2. All right. So you can do it one at a time. Now, when you're doing your shifts, it really doesn't matter what order you're going to do shifts in, right? You just have to make sure that you're keeping track of how the rule changes. So suppose I would like to have, instead of x squared, I'd like this x minus 3 squared. So how would that be done? How would the rule be changed? Well, that would be by, say I would replace all the x's in this rule. Replace the x's with the quantity x minus 3. Well, remember on my previous page, talking about horizontal transformations, when you do this, when you replace the x's with x minus h, that's going to cause a horizontal shift in the graph. And the h here is 3, right? I'll even write that here, this h equals 3. If I think of that as x minus h. And that's a positive h, right? H is positive. So the graph, it will move to the right h units. I'm just going to be adding 3 to all the x coordinates. Right? So here's how the rule is going to look now. We'll have y equals, and instead of x squared, again, I'm going to change the rule to move this graph around. Instead of y equals x squared, we have y equals, replacing the x with the quantity x minus 3. Y equals x minus 3 squared. And I'm going to graph it in this, this light blue color here. All right. Okay, so all I'm doing is moving every single point on the red graph to the right 3 units. And I'll even write that here. That's right 3 units. Or right 3. Shift right 3. Because I replaced it all the x's with x minus h, and h was positive. So if I move this 0, 0 to the right 3, that's at 3, 0. That point will be on the graph, and you can double check. When x is 3, is y 0? Yeah. 3 minus 3 is 0. 0 squared is 0. Yeah. 1, 1 would move to the right 3 to be at 4, 1. Negative 1, 1 would move to the right 3. Again, I'm just adding 3 to the x coordinate. So negative 1 plus 3 would be 2. So 2, 1. And again, double check these if you want. When x is 4 in this new rule, would y be 1? Yeah. When x is 2 in this new rule, would y be 1? Yes, it would. And I'll do it to all these. So this right 3 units, that'll be at 5, 4, right? x5, y4. This to the right 3 units, that'll be at 1, 4, when x is 1, y is 4. And again, those are solutions to this equation. You can always double check all these. And you see how the graph, is every single point, not just these 5 points, but every single point gets moved to the right 3 units when I replace all the x's with x minus 3. And we get the same shape graph, but just shifted right 3 units. Right? So there's y equals the quantity x minus 3 squared, right, in blue. All right, so now I'm going to do in a different color. Hopefully it's an easy to recognize or easy to differentiate color. Next, now I have this rule, right? We're at this blue graph now, so kind of ignore the red graph, right? That's where we started. Moved over to this blue graph now, and then I want to change this rule to look like that one. So see how I would keep the rule the way it is, right? That gives me this x minus 3 squared. So I leave the rule the way it is and simply add 2 after the rule, right? And that goes back to the first page I had. The first page, see, when I just add a number to the original rule, right? The rule I'm starting with here is this x minus 3 squared. That causes a vertical shift. So all I'm doing is adding 2 to the rule. And this is a positive 2. All right, that's the k. K equals positive 2. And again, back to that first page. If that is a positive number, the graph will be shifting up k units. I'll be adding this k. I'll be adding 2. I'll be adding 2 to all the y coordinates. Right? So we'll get a shift up 2. I'll just write up 2 in parentheses. Alright, so that's going to be this rule down here. Y equals, this rule, I'm going to leave it the way it is because it looks exactly like this part of the rule I want, and then add 2 after it. And this is our f of x, right? This is what we're asked to graph, right? This is the rule I'm looking at that I was asked to graph in the instructions. So yeah, so I just take I'm going to graph it in this, again, it's not maybe not the easiest to tell, but I'm going to graph it in this magenta color. It's a little off red. But I'm taking my blue graph here, and all the points on the blue graph are now going to be moved up 2 units. So this point here, 3, 0, up 2, be at 3, 2. Then 4, 1. Add 2 to the y coordinate will be at 4, 3. And then 2, 1 on the blue, up 2 units will be at 2, 3. Then 5, 4 on the blue, up 2 units, be at 5, 6. Then 1, 4 on the blue, up 2 units will be at 1, 6. And again, it's very, like I said, it's pretty cluttered here. I am going to be drawing on a separate page this final graph all on its own. And then double check, when x is 3, would y be 2? Yes. When x is 4, would y be 3? Yeah. When x is 5, would y be 6? Of course, right? All those ordered pairs are solutions to this equation. And I draw the rest of them in, because it's all the points on the blue graph getting moved up 2. And you get the same shape, right? The shape didn't change. So here's y equals, the quantity x minus 3 squared plus 2. That's the f of x that we were asked to draw. All right, so in this example, I did, horizontal shift first and then vertical. I'll do in the next example, vertical then horizontal, and it really doesn't matter as long as you keep track of what the rule looks like, the function rule. Alright, so like I said, I'm actually plot this on its own page, and we'll label some points and stuff, right? So here's f of x equals x minus 3 squared plus 2. Alright, and that was this magenta graph here. So I had the point, 3, 2. 3, 2 on it. And the point, 4, 3, and the point 2, 3. And it asks for 3 points, label 3 points. I'll put 5, right? That's 5. So I had 5, 6, right? 5, 6, and 1, 6, all on the graph. And there's your final graph right here. After taking y equals x squared and shifting it to the right 3 units and then up 2 units. And again, let me label these points. There's 3, 2. There's 4, 3. 5, 6, and it said label at least 3, so there's 3 there. All right. And again, double check, make sure these ordered pairs. Don't just blindly believe in a graph. Check your solutions. I always say that. Check your solutions. Always make sure that these points you're plotting actually satisfy the equation you're graphing. Okay. So that's one example. All right, and again, in that example, I did my horizontal translation first, and then the vertical translation, right 3, then up 2. But you'll see in this next example, it really didn't matter that I did it in that order. It's really just what you prefer. Just make sure that you're keeping track of how the rule's supposed to look. All right, how are you changing the rule? If you're simply adding a number to it, that's a vertical transformation. But if you're going through the rule and replacing all the x's with x minus something, x minus 5, x plus 7, which is minus negative 7, that's going to cause horizontal transformations. So just keep track of how you're changing the rule. All right, so I've got one more here where I have the same instructions. All right, I have this quadratic, you have an x squared. You're going to have an x squared if you were to multiply that out as your highest power of x. I've got this quadratic function that I'm again asked to graph using these transformations, right? These horizontal and vertical shifts. And so if I'm asked to do that, what I'm going to do is start with the most basic, right? This is a quadratic. I'm going to start with the most basic quadratic function there is, y equals x squared. All right, and again, I'll do that in red. 0, 0, 1, 1. Negative 1, 1, 2, 4, negative 2, 4, and again you can plot other points if you want, but there's the same one I started with last time. Anytime I'm asked to graph a quadratic using transformations, this is the quadratic I am going to start with, right? The easiest one, the most basic one. All right, now let's see how this moves. All right, now last time, right, I said, let's replace x with x plus 1 or x minus 3, whatever it was. I did the horizontal. I did the thing inside first. Let's do the thing outside first this time. So how about I want this minus 4 in there. So I'm going to keep the rule the way it is, x squared, and just subtract 4 from that rule, which is the same as adding negative 4. Right, so the value of that k on the first page would be negative 4. Again, remember the first page is talking about verticals. If I add a k to a rule, right? So here k is a negative number. The k is negative 4. So subtract 4 from the rule, x squared, k is negative 4. That's going to move the graph down 4 units, right? So I'm doing my vertical transformation first. Let's see how that rule would look, that equation would look. We'd have y equals, instead of x squared, again, I leave x squared the way it is, and I pop this minus 4 that I want at the end. All right, so we're going to graph this next. All right, so like I said, if you want to make tables, fine, nothing wrong with that. I like doing it for most functions, but again, if you know the transformation that's occurring, if you know how the graph is going to move, that'll be a little bit, it's basically you can skip the table and move the points. A little bit of a shortcut. So 0, 0 on the red graph would move again down 4 to here at 0, comma negative 4. and check it out. When x is 0, y would be -4 in this rule. 1, 1, moving down 4. Again, I'm just subtracting 4 from all the y coordinates, right? Or adding -4, right? Adding that k to all the y coordinates. So 1, 1, when I go down 4, would be at 1, -3, right? 1 minus 4. -1, 1 would be at -1, -3. 2, 4 would be at 2, 1. I'm sorry, 2, 0. Right? Down 4, I said. Right? Then -2, 4 would be at -2, 0. Again, check. When x is 2 in this rule, would y be 0? Yeah, 2 squared is 4. 4 minus 4 is 0. Same thing for -2. So again, all the points on the red graph just got shifted down 4 units with this simple subtraction of 4. So it's the same shape. The shape doesn't change. Still this same looking parabola, just down 4, whereas y equals x squared minus 4. All right. And then, so that's first step. And then the only other thing I would need to do, right, now I'm working with this rule. Right, now we can almost ignore the red graph. We can ignore y equals x squared. And now imagine I'm starting here. Now we're on the blue graph, right? Y equals x squared minus 4. So starting here, I want to change this rule through one little step. I want to make one little change to this rule to make it look like the one they want. Well, all that would need to be done is I would have to replace x with the quantity x plus 1. So let me write that in. So I'd have to now replace x with the quantity, all the x's, well there's only one x, but I'd replace all the x's in the rule with the quantity x plus 1. Well, remember, on that horizontal page, talked about replacing x with x minus h, right? So x plus 1, that's really x, minus -1. So the value of h here is -1. Right? When I talk about replacing all the x's with x minus h, well, if you replace x with x plus a number, that's really minus a negative. So the value of that h is -1. And remember how that does the transformation, that moves the graph left. This blue graph, all the points are going to move to the left 1 unit. All right, let's see how the new rule would look. Okay, and I'll do this maybe in a more distinguished color. Got pink here, right? I don't know if that's any different from the red in the video, but this is like a pinkish, right? So I take my old rule and replace all the x's with x plus 1. So instead of x squared, I have the quantity x plus 1 squared, and then you have the minus 4 after. And this is the f of x that we're talking about. This is the graph of f that we're trying to make. All right, so again, all that's going to happen is that this blue graph, y equals x squared minus 4, all these points move left 1, or I'm going to subtract 1. I'm going to add -1 to all the x coordinates on the blue graph. So you have 0, -4 would move to the left for -1, -4. And double check, when x is -1, would y be -4 in this rule? Yes, it would. Then this is 1, -3. Move left 1 to 0, -3. And double check, when x is 0, would y be -3? Yeah. This point here on the blue is -1 for x, -3 for y. Move it left 1. That's -2 for x, -3 for y. Alright, and then this point is 2, 0, moves over to 1, 0. This point's -2, 0, moves over to -3, 0. Alright, so again, I just moved these 5 points, but all the points on the blue graph move left 1 unit, and I get the same shape. And again, I'm going to draw this on a separate piece of paper so it looks cleaner. But there's the graph of y equals, the quantity x plus 1 squared, then minus 4. Right, this pink parabola. Very cluttered, I know. But again, I'm going to clean it up, draw it separately on its own page, on the next page. All right, so keeping that up. So here it is, another set of coordinates here, x and y axes. All right, so we had this pink graph, the final graph, the f of x equals x plus 1 squared minus 4. You have -1, -4 on it. Right, so there's that location. Then we see 0, -3 is on it, and again double check, check it in the equation. When x is 0, would the output be -3? And yes, it would. Alright, then -2, -3 I'm seeing. So this location. And I'll label some of these points, right? And then 1, 0, right? And again, please, I know I say this a lot, but double check. When x is 1, would the output be 0? Yes, it would. 2 squared is 4, minus 4 is 0. And then -3, 0. And double check that ordered pair as well. Alright, and then all these points, all the points on the parabola. Draw the rest in. There you go, and there's the graph of f of x. Right? There's the graph of f. And labeling some of these points. Here's -1 for x, -4 for y. 0 for x, -3 for y, 1 for x, 0 for y, and again you can label the others. I'll do it. Right? -2, -3, and -3, 0. Wonderful. All right. So again, the big things to take away from this video are: when do transformations occur? Right? You have to basically keep track of how you're changing the rule. Alright, so if you're just simply adding adding a number to that original rule, the graph of that thing will move up or down. And if you're simply going through and instead of adding something to it, if you're going through and replacing all the x's in the original rule, replacing all the inputs with some quantity x minus something, x minus a number, or x plus a number, right? Plus a number is just minus a negative number. That'll move the graph left or right. So just keep track of how you're changing the rule, and that'll tell you which way the original graph, the graph you have, is moving. Okay. As I like to say at the end of these, do the best you can to learn the material on your own before you go looking for help. I have found over the years that people who take the time and the effort to learn something on their own tend to remember that material better and remember it for longer and are more proud of it. So obviously read the material, right? Read through the author's examples, perhaps even try to work out the solutions to an author's examples before you see how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Obviously do tons of exercises, practice problems. Right? That's the only way to get better at anything, is practice. Check for solutions to those if they're made available to you, so you can keep track of yourself, keep track of your progress, see how you're doing. And don't just give up on a problem after one attempt or two. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several attempts at a problem, you're still having trouble, I would suggest you actually go back and read the material again, perhaps even a third time, more slowly, more deliberately. Take good notes. Because if you've been working on problems, as you should, you'll get a better idea as to what the author finds important about the material, what the author wants from you, what the author's asking from you in that section. So when you go back and read it again, or that third time, you'll know better, what to look out for. You have a better feel for what the author feels is important. So you'll be looking more for that in the material, in the reading. And who knows, maybe even some other things will pop out at you that didn't the first time through, and it'll make things make more sense, and perhaps even make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at the problems, you're still having trouble, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online. There's loads of those too. Videos like this one, or plenty of other ones out there better than this one. I assure you they're out there, and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I feel that this is the hardest thing for most people, stay positive. Believe in yourself. Believe in your abilities, even through the struggles and failures and mistakes, frustration. Because it's in those moments of struggle and failure and frustration that you actually have an opportunity to learn the most, and also learn the most deeply. Because if you can persevere, if you can persist and make it through your frustration, get past it, and learn how to fix your mistakes, you'll remember that material far better and far longer than someone who got it right the first time and just breezed through it and never gave it another thought. All right, so stay persistent. All right, keep at it, keep practicing, stay positive, and don't give up. And I'm sure you'll get it. I believe in you. And thank you very much for watching.